I'm Habib Ali. I'm the founder and CEO for Behavioral Health. Behavioral Health is a company which strongly believes that there's no such thing as a disabled person. There's only bad design and disabled technology. So we are actually in the business of enabling lives through good design and technology. Stroke is more common than you think. There's a stroke which happens every 2 seconds globally. There are three strokes which happen every minute in India. So after stroke, a lot of people suffer from something called as hemiparesis or hemiplegia, in which one side of the body is paralyzed. The upper limb takes a lot of time to recover, and more than 80% of the people have an upper limb disability. The course of treatment, in a very short gist, would be medical treatment followed by initial physiotherapy and then discharge to home. So once the patient goes home, for them to travel back to the clinic and do therapy becomes difficult because they have to travel or either call a physiotherapist home. But even if they do that, doing the therapy becomes a monotonous and burdensome activity with no scope for new things happening over there. And people usually tend to drop out of therapy and they deny themselves a chance of recovery, which is possible. So, research suggests that you need a lot more repetitions than what actually happens in the clinic. During my fellowship at the Center for Healthcare Entrepreneurship in IIT Hyderabad, we followed a biodesign process to understand the need in depth. So, during our research, we found out that the number of repetitions done for the upper limb is around 30 per day. And even if it's an inpatient center, you might have it done twice or thrice a day, which is maximum of 100 or 120 repetitions in a day, which is much less than what the research suggests. Research says that you need at least 400 to 600 repetitions every day to enable recovery. There was a conception that people cannot recover after the initial 6 months, but now research turns around and says otherwise. There's a very good paper published of a person who recovered his arm function 21 years post stroke due to intensive therapy. So these are the things which motivated us to go forward, and we found that there's a very specific need for an intensive and engaging rehabilitation therapy for people with upper limb motor deficit. And this is required both at the clinic and at the home, and without compromising the quality of therapy, which is currently happening. So we have designed a solution which is a very interactive arm training rehabilitation device. It's called ArmAble. So ArmAble is a smart device which allows for a high throughput. It connects the patient with the therapist by allowing tele-rehabilitation. The therapist can set individual goals according to every individual patient, and these go in the form of games to the patient. Patients usually get immersed playing games and forget that they are doing therapy, and they're motivated to keep doing it. But what also happens is their movement data and the performance is monitored on a regular basis and is quantified, which never happened before. Now, this quantification shows that even if there's a minor improvement happening, and when a patient is able to see even a minor improvement, it encourages and motivates them to continue. So, all of this data is stored on the cloud so that the therapist can access and see how the patient is doing and modify it accordingly. And the patient is actually seeing himself improving and he continues to do his therapy. So, on the usability aspect, we've tried to do a lot of research and brainstorming to understand what goes good. We have simplified our technology and design to such an extent that the ease of usability is there for the patient and also for the therapist. So we are leveraging things such as bilateral and bimanual therapy and also unilateral therapy. We are leveraging neuroplasticity and also serious games to enable people recover and perform therapy much more than they usually would. He is Srihari. Srihari is also the co-founder for Behavioral Health. So, as a part of my fellowship, when I was doing my research on stroke and understanding the problems around it, so on campus we get to interact with a lot of people and discuss different perspectives. So, Srihari had a very interesting perspective about an incident which had affected his family, and that was very close. And this really, his personal experience about this made us realize that there is actually a need for getting quality of therapy at home as well, because it's really difficult for people with hemiplegia or hemiparesis to travel to the clinic every single day.
So the story was, uh, so it actually happened in my home. My uncle got stroke and he was one side paralyzed. Now the whole problem was like there is no quality therapist available because he was from a little remote part of my village, and it was very tough for to find a therapist to come to home and do everyday therapy, and this became very tough for the family to take care. So, and within 3 months he passed away. So that became very shock to me. So I have all the way traveled back to my village, see my uncle, and while coming back from my village, I actually searched and found out there are a lot of families that is actually suffering from the similar situation, not only me or my family which is gone through. So we were discussing the same thing to how can we find a solution to this problem by intervening design technology into this area to find out how we can actually give quality therapy and connect therapist to the patient in the same system. So that's how we actually made into a device that actually connects therapist to the patient with the quality of therapy without compromising on the quality of the therapy, but enhance the quality of the therapy by itself. So this help to monitor, this device helps in monitoring the therapy and make sure that the progress is being shown, and this can be quantified. And that's how the whole scenario of this device came up.
So this incident actually was a turning point in a lot of ways. So one of it was, it made us realize that we need to get this out as fast as we can, and that uh, gave us a sense of urgency in doing things faster. It also made us realize that the way it has to be done, the way the device has to be addressed, how the design has to be in terms of taking it home and making the patients use it. So that was something also which gave us perspective. So keeping this thing which happened, uh, keeping this thing in mind and keeping that as one of our foundations, we've constantly started working with different rehab centers, and Sahara Rehabilitation Center is one of the places with whom we've interacted constantly to understand the needs and evolve our design to such a way that it can actually and go home to the patients. So we did an initial usability test with our device with around 8 patients. One of the patients which we have was having a left hemiplegia post-stroke, and on day one the patient was a little disoriented on how to use the device. But as the days progressed, his body language and enthusiasm to use the product really improved. And at around the 10th day, he had improved his arm function to an extent where he could actually lift a ball. So his arm was flaccid, and now he was actually lifting the ball, which gives goosebumps. And then on the 15th day, he was using the device with his arm, which was previously paralyzed. So, if we look at the science behind the product, so we are leveraging basic concepts of neuroplasticity and biomechanics. So, according to neuroplasticity, according to the latest research out there, the more number of repetitions and the higher the intensity of therapy, the better the recovery. So, currently, the number of repetitions which happen in the clinic are around 30 to 40 repetitions in a day, but the requirement is around 400 to 600. There's no way a physiotherapist can sit and make every individual do 400 to 600 repetitions. So in that place is where our device comes in. So we use games which actually make the patient immersed, and they forget that they're doing therapy, and they keep continuing to do it for such an extent that they don't realize that within an hour they have done more than 600 repetitions. So that's how we are trying to leverage neuroplasticity by training and making sure that there is more cortical reorganization of the neurons, and leverage more about the neuroplasticity in the best way which is possible. But when we look at the functional aspect of the arm, when we look at the biomechanics of it, we've made our device function in such a way that it covers full range of motion for the arm in different planes, uh, and also include different kinds of uh, games which are more related to activities of daily living to which patients can actually relate to and start training in such a way that their arm function starts correlating with their activities. For this particular product, our company has been able to raise an initial incubation grant from the Center for Healthcare Entrepreneurship and a grant from BIRAT, which is the BIG grant, for taking our idea forward. We have two versions of the device. One is the clinical version and one is a wellness version. Both of them catering to different markets but addressing the same need. And we are looking to roll out our wellness version by mid 2019, for which we are already in discussion with a few partners and distributors, and we are figuring out our channels on how to place it properly. Uh, the idea why we need a clinical and a wellness version is we want the patient and the therapist to stay connected even after the patient leaves the hospital. So for making this happen, the clinical version and the wellness version communicate with each other, where the data is shared from the home, where the wellness version is placed to the therapist, and it's all synced on the cloud, where we have all the analytics about the number of therapy, the number of sessions, the duration, and all such parameters which are required to quantify the therapy. To deliver the seamless experience, we also require a good service team. So we are building that and putting that also in place to cater to this device. I'm from Hyderabad. I'm actually a biomedical engineer. I've done my master's from Manipal Institute of Technology, after which I've done my fellowship in healthcare entrepreneurship at IIT Hyderabad. I'm very enthusiastic about robotics and games, and I've started integrating games and robotics. I have a fascination for building my own Iron Man, which is basically an exoskeleton, and we started with a project for a lower limb exoskeleton in college for people with lower limb paralysis, which is basically paraplegia due to spinal cord injury or any other such incident. So that's integrating mechanical electronics and implementing them into medicine and seeing how different things happen, integrating things with the most complex thing in nature, that is the human body, is what excites me.